Today's lesson is limiting reactants. Limiting reactants are sometimes a struggle for students, but they're just a way to think about when will I run out of a certain substance. All right, the limiting reactant is always going to be the substance that you run out of first. Another way to think about it is it's going to be the substance that leads to the least amount of product produced. Okay, so let's think of a metaphor first. I'm going to give you a fake chemical reaction, right? And we're going to think about it. If I need one piece of dough and 5 chocolate chips, to make one cookie, let's call this my chemical reaction. This is balanced. Let's think about it. If I had 7 pieces of dough and an unlimited amount of chocolate chips, then I could make 7 cookies because the ratio is 1 to 1. If I had an unlimited amount of dough and 50 chocolate chips, then I could make 10 cookies because the ratio is 5 to 1. But let's think about a scenario where I have 7 pieces of dough and 50 chocolate chips. Well, how many pieces of cookies can I make then? The answer is still 7, right? So let's think about this. For every 1 piece of dough, I can make 1 cookie. So I have 7 pieces of dough, and I'm going to make 7 cookies. And because of that, each one of these cookies has 5 chocolate chips. So I will have used up 35 of them to make these 7 cookies, and I'm going to have 15 chocolate chips left over. And it's okay that I have left over, but that just means that I'm done. I might have 15 chocolate chips still sitting on my kitchen table, but I'm all out of dough and I can only make 7 cookies. Now, let's do a practice problem through chemistry. All right, this will be our reaction for today. 3 silicon plus 2N2 goes to Si3N4. Okay, and we're going to start with a problem where I have 21.44 moles of Si and I have 17.62 moles of N2. I want to know which of these is the limiting reactant, and then as a bonus, how much of the other reactant will I have left over at the end of this reaction? In order to figure out which one of these is limiting, we need to figure out which one is going to lead to the fewest moles of Si3N4 produced. So let's start with silicon. I have 21.44 moles. And the ratio is 3 to 1. So 3 to 1. This means that if I had 21.44 moles of Si and unlimited nitrogen, I would produce 7.15 moles of Si3N4. Let's think about it from the other angle here. I have 17.62 moles of N2. The ratio is 2 to 1, 2 to 1. And that's going to lead me to 8.81 moles of Si3N4. So with this 21.44 moles, I was able to create fewer moles than with this. That means that Si in this case is limiting, and the amount that I will produce is 7.15. second part of this equation, this problem we can figure out is, okay, so we produced 7.15 moles of silicon nitride. Now, how much of my 17.62 moles of nitrogen is left? To think about that, we just have to go backwards. I have 7.15 moles of Si3 and 4. The ratio of these is 1 to 2. 1 to 2. And my answer is 14.3 moles of N2. And this number here is the amount of N2 that I used to make 7.15 moles. So to see how much I have left, I'm going to do 17.62 minus 14.3, and you get 3.32. Now, how to interpret this whole thing overall? What it means is if I had 21.44 moles of silicon and 17.62 moles of nitrogen, and I combined them, I would produce 7.15 moles of Si3N4. I would have 3.32 moles of N2 left over. Think about it like on my kitchen table, it's left. And I would have no silicon. I will have used all of it. Hopefully this helps with limiting reactants, and I will see you next time.